Give modern AI a prompt, and it spits out hundreds of lines of code in seconds. The velocity is intoxicating. But jumping straight from a human idea into raw script is dangerous. Without a plan, you get broken architectures, ignored edge cases, and immediate technical debt. The biggest casualty is context. The second the machine generates a massive file, the original reason for why a feature was built that specific way evaporates from its memory. To solve this, a tool called RPD, the Requirements, Planning, and Development Workflow, acts as a structural brake on AI coding agents. RPD applies a methodology called spec-driven development. It physically stops the AI from typing any code until it has planned and verified exactly what it intends to do. Instead of letting the AI run wild, RPD forces it through a strict series of gates. Developers use 2- or 3-letter commands to drive a deliberate step-by-step process. Engineering speed requires these breaks. Without them, fast code just means failing faster and building a mess you can't easily untangle. Here, the workflow begins with intent routing. The system evaluates your request to see if it's a simple, localized fix or a broader structural change. If your request touches a public API, changes security protocols, or carries unknown variables, RPD rejects direct implementation. It forces the AI into planned routing. This flowchart shows the start of that planned pipeline. The thick path routes the AI to generate a REC, or requirements document. The system explicitly defines the problem and acceptance criteria. Once locked, the workflow moves to the AP, or architecture plan. This breaks the project into dependency-ordered phases and specific test specs. These REC and AP files aren't temporary chat logs. They are saved directly into a dedicated .docs folder, securing your intent. Before a single line of code is written, the system hits the AR gate, architecture review. The pipeline completely halts here. To clear this gate, RPD deploys a separate, independent AI subagent. This reviewer is given a completely clean memory. It reads the requirements and the plan, hunting for vague assumptions or missing validation. A primary AI agent will often confidently agree with its own bad ideas. By forcing a clean break in context, this independent review catches flaws while they are still just text on a page. Returning to the flowchart, once the plan passes review, the barrier lifts and the system begins SS, or step-by-step implementation. The coding phase is highly constrained. The AI is only permitted to execute the approved plan, preventing it from spontaneously hallucinating new features. After coding, RPD triggers unit tests and end-to-end tests to prove the code compiles and functions mechanically. But passing tests isn't enough. The pipeline loops back for verification, or VR, comparing the functional code directly against the original REQ document to ensure your goal was met. In the real world, human minds change midstream. You might realize halfway through development that a feature needs to work differently. For that, RPD uses a verified restart protocol triggered by a double exclamation mark command. This safely pauses the flow, reconciles the new requirements into the documentation, and restarts the architecture cycle. Execution without verification is just typing. RPD's continuous checking ensures the final output matches exactly what you requested. The final steps lock the completed work into place. The AI generates completion documentation, summarizing what changed, and executes a Git commit to save the files. This commit serves a specific purpose. It is permanently tied to the exact requirements, plans, and testing evidence, safely stored in the .docs folder. Over time, this creates a deeply searchable knowledge base. When a new developer joins the team, they don't have to guess why a strange function exists. The full history of the decision is sitting right next to the code. Traditional AI coding treats software like a sprint, leaving behind an undocumented wake. RPD treats it like structural engineering, favoring long-term stability over chaotic short-term output. By fusing the history of human intent with the history of the code itself, RPD keeps your software readable, reliable, and safe.